Hi friends, let us see how the minimum element in the main heap can be deleted. So that's an example we have, which is shown in the list form, and below we have shown the same thing in the tree form. Okay, when we need to delete minimum, that means this node has to be deleted. So just by deleting this node, the whole tree gets disturbed, so it cannot be done. So deleting a node means root should be disturbed. Second, the number of nodes reduced by 1. So when the number of nodes reduced by 1, in this case there are 11 nodes. So when root is removed, then there has to be only 10 nodes. That means this node should not be present instead of this node. So what is the option? Option is this popped root element, so that you can further use it. And second thing is copy last element into root. So that way what happens is, on the last element it was 12, and that's put in place of 1. So 1 comes out, so 12 comes here, and this node no more exists. Done. Now, can I call this min heap? Of course not, because minimum has to be on the root. Okay, then looking carefully, what else? The next minimum possible? The next minimum possible is 3. How do you get that? So, because this is a min heap, then any subtree you look at it, the root has to be smaller than the other elements. So if you look at a subtree with the root at node 2, then you can see that 3 is the smallest element in this. Same way, a subtree with a root at node 3 is having 5 as its smallest element, and so on. So one thing is very clear: as you go to the next layers, as you continue moving down the layers, the values keep growing. Therefore, the smallest possible values are found on this layer only, that is second layer. So what is to be done now is this one of these two should occupy the root. So the smallest of the two has to occupy the root. So it works out that the value 12 and 3 are swapped. So 3 comes here, 1 comes here. Now, is this 12 in right place? So look down at its subtree, then you find that the children of 12 are 7 and 11. Of course, both of them are smaller than 12. Therefore, you can't keep as it is. Therefore, smaller of them happens to be 7. So replace or swap this value with 7. Now, finally, this one gets replaced. So 8 comes here and 12 comes here, And if you look at it, 3 is followed by 5 and 7, so they are in right place. 7 followed by 8 and 11, right place. 8 followed by 12, they are in right place. So at the end, this has become a correct min heap, and now the whole thing has changed. So what has happened, as 3 has come here, and in place of 3, 7 has come, 5 and remain same, 11 remains same place, and then at the fifth place it is 8, and at 10th place it is 12, and the 12th place is empty. So 3, 7, 5, 11, 8, 9, 6, 11, 8, 9, 6, and 14, 16, 12 are the right things. So how this is to be done on the algorithm way, let us see in detail.